know. When I was so excited, I was like,
Look at the names.
yeah, but I didn't know what time slot because I wasn't at the meeting. And no one told me what time
Oh,
slot.
you have a certain time slot?
Yeah, you have to be in a certain time slot.
Like nobody has to be?
Yes.
Oh,
I should sign
yeah.
up
I
for
said
it.
there was certain people.
How do I check?
I
Put
don't
in my
know.
calendar.
It was supposed to be like 10 something, I
Oh,
think.
yeah, I didn't do
I'm not
that.
doing it, no, you.
I think it was-
Kelly's blind dogs here, 11:15 to 1:30.
Yeah, no, I think it was supposed to be
I
earlier.
wonder if Rebecca Riley didn't stand for that.
Oh, but, I love it. Mine will be fine. It's just, I think new people were supposed to stay with new.
I gotta do, what are we doing today?
You know,
Doing
due
anything?
to Corona, maybe.
Yeah.
But, I think you're fine.
Okay,
Nah, she'll be good.
We can't do anything about it now. You're like, sorry, you can't.
all right, we have a new topic for today.
That's you.
Hopefully it's not too bad.
New topic.
Yes. All right, this is a site, you guys can follow along with some of this if you'd like. This is called Desmos.com. It's got a nice graphing calculator. So if you go to Desmos, right up front, you just click graphing calculator. We can create like a little classroom and stuff and give you guys activities. We're not going to do that just yet, but probably eventually. But go ahead and, if you want to follow along, you can go to the graphing calculator. That's what this is. Lets you zoom in. It gives you a nice grid. You can see little points. Right now, I only have visible this point at the origin. Oh, hold on. I'm gonna let's do this real quick. There we go. So I got this point at the origin, 0, 0, and you see it there, that blue dot. And 1, 1 is another point right there. Think of this like it's an arrow. So you've got like the base of an arrow at the blue point, and then the head of the arrow stretches out to the green point. I can't really make it draw an arrow easily, at least I'm not sure how. So just imagine that this is a stretched arrow connecting 0 to 1, 1. Does that make sense? All right. So what I want to talk about was sort of transformations of points, and this will eventually, we'll start talking about doing this with equations and functions, but I just wanted to do it with points for a second. So just working with, let's say this 1, 1 point. If I, well, I'll do another one, I guess. So here's 1, 1 again. And now the black point coincides with the green one, so you kind of overrides it. If I take the x value, though, and let's say I add 1 to it, you'll notice that the point now shifts to 2, 1. Does that make sense? So if I add numbers to the x coordinate, it moves right by that amount from where it was. Does that make sense? Similarly, if I do the y coordinate, if I add 1 to this, it goes up 1. If I add 2, it goes up 2. So I can sort of move these points around with these sorts of transformations. What you can also imagine doing is multiplying the values by something. So 2 times the x value, you'll notice doubles its distance from the y-axis. So there's this horizontal, like this distance from the y-axis, you have to go parallel to the x-axis, 1 unit. But when I multiply that by 2, it's now stretched to be twice as far from the line. If I multiplied it by 3, it'd be 3 times, 5 times, 6 times. I can, somebody else got a sub. So that allows me to sort of stretch it horizontally. Does that make sense? We okay so far? If I do the same to the y, it does the same. So 2 times the y, 3 times the y, 4 times the y. It just stretches it vertically now. If I multiply by a negative, if I flip the sign on one of the coordinates, so I'd say x is now minus, it mirror images across the vertical axis. The x got swapped to negative. If I did negative on the y, what do you think would happen there?
Go down.
Yeah, we call these reflections. Reflection across the horizontal axis, reflection across the vertical axis. So negatives sort of flip the direction. So if before this was an arrow from 0 to here, you thought it was an arrow, now the reflected arrow is pointing this way. If I do both of them at the same time, it reflects them across the horizontal axis and the vertical axis. So now this is actually the opposite arrow to the other one. It's the same length, but it points in the opposite direction. Are you guys okay with all of that so far? Yeah. All right. Yeah.
Are we gonna get a final study guide?
What do you mean?
Like to study for our final?
There'll just be another test. It's not like a cumulative final,
It's not a final, it's just
another test.
over something totally different.
Oh, what we're talking about now.
Okay.
So,
Starting from right now,
Yeah.
That's where we're starting.
so start taking notes. Okay, so now I'm going to look at this function. We had a linear function. This is y equals x, so it's a very basic function, right? I've decided to go ahead and put parentheses around the y and parentheses around the x because I'm going to be doing things to the y part and the x part separately, and I kind of want you to think of them as two parts, okay? There's these two parts. And what this basically means is that the value of the y is equal to the value of the x. So when x is 1, y is 1. When x is 2, y is 2. When x is 4, y will be 4. So it's just y is x. That's all that says. And this is the equation of a line. But the topic that we're on right now is we're going to stick with lines like this, y equals x. And this is just one particular line, y equals x. I could have done y equals 2x plus 1, and I got a different line. Or I could have minus 1/2 x plus 3, and I have a different line. And when I have two lines, where they cross is the solution to a system of equations, just like we were doing before. And that point would represent the solution here. But what we want to do is talk about this concept of transformations. What we do with functions is we organize them. So this is called a parent function. Rarely it might be called like a mother function. These mother functions have daughter functions, whereas or you could have a parent function and the child functions. Any line could be considered the base line, and all of the lines are sort of transformations of that. We go with the simple one, so y equals x, we refer to as the parent function, and all of the lines we can think of as transformations of this line. So we're just going to go over how you can make other lines by transforming this line. So right now I have the point 0, 0. That's the origin. And think of that as sort of like an anchor point for this line, y equals x. okay? So right now, y equals x is the line, and think of 0, 0 as some anchor point that I want to keep track of on this line. All right, so if I go to the x part, this little x here, and let's say I say +1. I'm going to show that. And I get a new line, and it has different intercepts. It's a different line when I put a little +1 here. And the way we want to think about that is when I put a +1 here, it moves the line to the left 1 unit. So instead of 0, 0, my anchor point has become 0, -1. So I put a +1 on the x part, and my x value of that anchor point went left 1. It's kind of the opposite of what you might think. Is that okay so far?
So by making it +1, it moved over 1 unit, making it -1.
Yeah, it went to the left, actually. It's kind of confusing because the line goes left when you add 1 to it for some reason.
So if you subtracted 1 from that, would it go right?
What do you think?
I think it would. Which is opposite.
Yeah, so now it's at +1 because I put a -1 here. And it's kind of backwards, but you can kind of imagine that you're not moving the line, you're moving the coordinate system. We call these transformations of coordinates. So if I tell the coordinate system to go left 1, it makes the line look like it went right 1, if you kind of steady your view on the coordinate system, right? I could say -2, and I'd go right 2 if I put a -2 on the x part. Does that make sense so far? All right, now,
Can you have us like graph this?
yeah, yeah,
How would, like, we just have to know that like when it's -2, it goes.
to the right 2, yeah. Think of the parent function, memorize the parent function, and then think of this as being the parent function with some transformations done to it. And so you'll imagine the parent function and you'll just shift it, or we have a couple of transformations that we can do. And so just being able to look at this and imagine that this is the parent function with some transformations done to it.
So then, is that a daughter function?
That is a daughter function, yeah.
Got it.
So,
Can we use those for the test?
yes. Now, notice when I said -2 on x, the line went right 2. What do you think if I said -1 on y? What do you think would happen?
Wait, what'd you say?
They go up to.
If I do a -1 on y,
They go up.
Down. You say minus, right?
minus, yeah.
It goes up. No, it would go up.
Yes, the opposite, right? It would go up.
Why is this going the opposite?
What's that?
How come it's going the opposite?
Because think about it like the coordinate system is being pushed. So if I push the coordinate system down while holding the line steady, the anchor point's no longer at the origin. It's now up 1 on the grid because the grid got pushed down, if that makes any sense. So I'm going to do another one, and I'm going to say y equals x. That's the parent function. But now I'm going to put a -1 on the y, and you'll see it goes up 1 unit. The anchor point gets shifted up. Does that make sense?
So adding one would make it move down 1.
Correct, yeah. Now, what's interesting is notice that if I add 2, the line would go down 2, and it'd be the exact same line as if I took the parent function and I went right 2. So now notice these coincide with each other. This one went down 2, this one went right 2, and they end up,
Still show up at the same thing.
yeah, they're equivalent. And if you think about it algebraically, if I have y equals x minus 2, I could just add 2 to both sides, and it would just move over here. So algebraically, these are equivalent. These are the same equation, just rewritten. But depending on where you put that 2, you can interpret it differently. When it's on the right side with the x, it made the line go right 2. But when it's on the left side with the y, it made the line go down 2. And it really doesn't matter which side you have it on. It makes the same line. But as we get to more complicated looking functions, it would matter more than it does with a simple line. Is that okay so far?
So basically, all we're doing so far is knowing that if you change y and x by adding or subtracting, it's going to move it left or right or up or down.
Yeah, and it's kind of counter. So if you do it to the y, it's going to move up and down.
Mm-hmm. And then x left and right.
Yeah.
Positive and negative going on.
It's a little counterintuitive though, because when you subtract from the x, the line actually moves in the positive direction. And when you add to the x, the line would move in the negative. So it's a little bit, you'll have to get used to that. But that's the trickiest part, maybe. Is that okay so far? Okay. I'm now going to put in 2 other dots. I'm going to go to, let's say, 2, 0 and 2, 2. Well, I'll do 1, 0 and 1, 1 just to make it a little bit simpler. Okay, now imagine you have a little arrow right here. So the line, remember, it's every input has an output. So when I input 2, the output is, I'm sorry, if I input 1, that's my input, the output is 1. This is my parent function y equals x. If I input 2, the output would be 2. Does that make sense? So when I take this parent function, here it is again, and this time I'm not going to add a number to the x. I'm going to multiply a number outside of the x. So I am going to multiply by 2. And what ended up happening when I did that is something that we call a horizontal compression. So what ended up happening was the input value was halved to give the same output value. Now, because I'm doubling the input value, I only need half as much as I did before to get the same output. So what it makes it do is you can kind of imagine this thing, this horizontal distance from the y-axis got halved. And this distance from the red line got halved to make the green line. And this distance got halved. I multiplied by 2 on x, and it horizontally halved, just horizontally. It kind of squished. Does that make any sense?
What if it was 3?
What do you think would happen?
Yeah, I don't know.
It's now a third, right? So if I go to not 1, but and not a half, but a third, I should have 1. If I went to 6, it would now be, well, I guess let's not do 6. How about 3? this distance, this horizontal distance from this axis to a point on this line got cut into a third of this line. So instead of getting to 2 when I'm at 2, I'll now get there when I'm at 2/3. Instead of getting to 3 when I'm at 3, I now get to 1. So I'm sort of squishing it horizontally. If I did, here's 2 again, so that's these distances this way have been halved. This distance has been halved. This distance has been halved. It makes it steeper, right? Kind of gives it a steeper line. But if I put a half here instead of 2, I've now done what's called a horizontal stretch. So this distance from here to here got doubled. Now it's here to here. This distance got doubled. So I've stretched the line. So if I divide, multiply by fraction, it stretches. If I multiply by a larger number than 1, it compresses. Is that okay?
I don't understand the last 2 things that well.
Let me see if I can draw something.
So what happens when you make it a half? What happens when you add half to x?
So here it is. I have y is equal to x. And I'll draw that. I'll try to anyway. Pretend that's really well done. And you can think of this as, since we're doing it to x, we're going to think of these horizontal distances. Okay? Now, if I change it to, let me do blue maybe. A half, you said?
Yeah.
That's going to be a horizontal stretch. So now I'm going to double all these, wherever double would be. I guess maybe here-ish. I'm going to double those. So if I did that, okay, it's going to kind of flatten it out, and these will double as well.
If it was 1/3, would you triple it?
Yeah, I would triple it, yeah. So if my point here was 1, 1 before, it's now 2, 1. If it was 2, 2, it's now 4, 2. And if it was 3, 3, it's now 6, 3. When I have. Is that okay?
So it elongates itself from the spot.
Yeah, when this number is less than 1, if you just multiply by 1, it does nothing. It keeps the same
Yeah.
line. But if I do it less than 1, it lengthens these distances. Because if you think about it, if I put in 1 for x, y isn't 1, y is half of that. I'd have to put in double in order to get the same 1 back. So it's kind of
But if you
stretched.
put a 2 there, it goes more straight up and down, does it not?
Yes, yeah. So if I did, I don't know, maybe orange. 2 of x, I would have these distances. And it would be a steeper line. So all these distances got halved. Is that okay? I'll do something similar, but with y's. Oops. So we'll say
So
y.
the line only gets longer when it's fractions?
What's that?
The line only gets longer when it's fractions?
Yeah, it stretches when you multiply by fractions. All right, here's the, well, you can kind of think of it as flattening out. So the red line was the original. When I multiply by a fraction, it goes flatter. And when I multiply by a bigger number, it goes steeper. So remember that the number multiplying x is kind of like the slope. So if I have a higher slope, it means the rise over run's bigger. So it goes steeper. And if it's smaller, that means it rises less while it runs more. So it gets flatter. All right, now when I mess with the y, we're going to think of these distances. So if I do, let's say 1/2 y of x equals x. Just like with the x value, when I have the x value, it stretched, it did a horizontal stretch. Well, if I have the y value, it's going to make a vertical stretch. So these distances are now going to double. I'll just do some of them. So when I do it to y, it actually gets steeper. So the distances get longer. It's just doing it vertically now. Whereas if I multiplied the y by 2, the distances would halve.
But even if you change the x by 2, wouldn't it be doing the same thing y by 2 would be doing?
Yeah, with lines, notice that if I have a 1/2 over here with the y, I could multiply both sides by 2 and end up with a 2 over here. That would give me the same. So notice this one with x is the same as this one with y. That they actually make the same line. If I stretch vertically, it's the same as compressing horizontally. Kind of does the same thing when I'm working with lines.
Multiply by 1/2 that line.
Which one?
The blue one,
Which side?
the Y.
Yeah, if I have it, I double the vertical distance. It has the same effect as having the horizontal distance. But think of it more as doubling the vertical distance at every point. If I doubled y, I would have those vertical distances.
Wait, when you multiply by 1/2, didn't you half that line? Half?
No, for this one, let me switch to green maybe. This one corresponds to this one.
Yeah, you cut it in half.
It didn't elongate or whatever.
It elongated vertically,
Yes,
but it's the same as having horizontally.
yes, sorry, that's what I meant.
Yes, yeah, they're equivalent transformations. And you can think of it like, well, if y is equal to 2x, I can divide 2 on both sides, and I'll get 1/2 y equals x. So this is really the same as this, it makes the same line. But this one you think of having the horizontal distances, and this one you think of doubling the vertical distances. It's the same.
Oh, when you do 2y, you elongate it horizontally.
Horizontally, yeah. But don't think of it that way, because this only is true for lines. When we get to other shapes that aren't straight lines, they aren't equivalent.
So think of it as like vertically.
Yeah, think of this one as a vertical doubling, double vertically. Think of this as half. How do you say? Just half, I guess.
Yeah.
Half horizontally. They make the same line, but you can think of them as different transformations depending on where you put that 2, what side you put it on, and is it a 2 or is it a half, depending on which side it's on. Is that okay so far? All right. I'm going to show you, I guess, going back to the other Desmos. I'm going to get rid of, let's say, I'm going to hide these points for now. Well, maybe I'll leave 0, 0. And I'm going to take this point. We have a red line and a green line. They're the same right now. But I am going to, let's say I'm going to do a horizontal compression. So I'm going to multiply by 2 here. And now this has been pressed in towards the y-axis. Horizontally, it's been smushed. So all those distances have been kind of smushed together. So it makes a tighter line to the vertical axis. But now if I come into the x and I say -2, notice that the 0, 0 point now shifted to 2, 0. It's still, the shape is still the same as when I didn't do that, but I can shift it
Still have the
and still have it be crushed horizontally. When I have these parentheses, the number here smushes or stretches it, either horizontally if you do it here, or vertically if you do it here. And again, it's kind of counterintuitive. If you multiply by a bigger number, it squishes it. We call it compressing. And if you multiply it by a fractional value, it stretches it, makes it wider. And again, to move it to the right, I subtract 2. Whereas if I added 2, oops, it would move it to the left. But I can do these 2 transformations in unison. I can squish or stretch the line, and I can move it around. Does that make sense? All right, I am going to let's try a few of these. I'm going to hide this line, and maybe you guys tell me what you expect. Oops, I want to hide it. If I do something like this, what's going to happen to that line?
Move it up.
Yeah, up 1, right?
Yes.
Nice. What if I do this?
Move it up and over left.
Left 1, right? So yeah, now it went up 1, left 1. So now it's kind of shifted this way. Yeah. What if I still have this? Let's say I put this and then this.
It's gonna go down one, right?
Yeah, down one.
And
Will it
it'll push.
It's gonna go
lines
like
out
this.
more.
steeper or flatter?
Flatter. Flatter. It'll be flatter because it's wide.
Yeah, and it's bigger than one, so yeah, it's gonna be this. So it's a little bit flatter, and it is down one. Does that make sense? Let me try another one. Let's try. What about this one?
You multiply all the points by 3. Triple
I'd triple the.
points.
So is it going to go flatter looking or steeper looking?
Yes. Flatter.
Yeah,
And then into down.
not down.
Oh,
No,
oh, left.
no. One.
Right.
Wait, what do you
Right
go
three, right three. Yeah, good. So it goes right three because of this. And then all of the horizontal distances triple, which makes this thing look like it's flattening out. Is this making some sense? So right now, the lesson for today was thinking of this parent function and recognizing things like if I add or subtract to the x, if I add or subtract to the y, that moves the thing around. It doesn't change the shape of it, but it just moves it around. It's multiplying on the x or multiplying on the y that kind of changes its shape. What happens, okay, I'm just going to take this regular line, y equals x, right? Think of the original line. What's going to happen if I put a 0 here? What happens if I put like a fraction there, like a half? What normally happens?
Or you triple it or double it.
Yeah, you stretch it out which way, horizontally or vertically?
Horizontal.
Yeah. So the smaller the number I get, the more I stretch it. The smaller the fraction, the more it. Like if I do a third, I'll triple that horizontal distance. If I do a fourth, I'll quadruple the horizontal distance. If I do a tenth, I will times 10 the horizontal distance, and it's getting flatter, right? So what do you think when I go all the way and I put a 0 there?
It's gonna go completely flat.
It is going to be completely flat, yeah. So it's there, y equals 0. You can't really see it. But if I shifted it a little bit, you would see that it has gone completely flat, right?
Any direction?
Yes. What do you think is going to happen if I put a 0 on the y? Oh, I just showed you, didn't I? Well, it's going to stretch the vertical distances, all the way until it goes completely vertical. If I put a 0 on the y. All right. Good. Is that making some sense to you guys? All right. So I'm going to show you a different function now. And we're not going to go too deeply into it. It's going to be this one. This is the one we're going to be dealing with a lot from now on. This is a quadratic. It makes a parabola. It's y equals x squared. But what do you think is going to happen if I put a -2 here? What happens if I put a -2?
We'll make it like open more.
Not open.
Close.
Remember when I'm adding or subtracting right now.
Do it. Would it move it?
It moves it, yeah.
Move it to the right too.
That's right, yeah. So now you've moved that little point of symmetry. We call it the vertex. It moved it from 0, 0 to 2, 0. What if I put a +1 here in addition to that?
So move it down.
Yeah, it'll move it down. So all we did, we switched the parent function, Cade, to y equals x squared. And then I made a couple changes to that. I subtracted 2 from the x, added 1 to the y. And it's just like with the line. It moved it to the right 2 and then down 1.
So the square is making it the curve.
The square is making it the curve, yeah.
Okay. So
Everything-
everything stays the same.
Everything's the same still, yeah. All right, good. I'm going to hide it again. And what happens now if I put a, let's say a 1/2 here? What do you think? What did it do before when I put a 1/2 on the x?
It's gonna elongate it. So is it gonna go like this? More
Wider, you mean?
wider?
Yeah.
Let's go. God, I'm getting math again.
Good. So that should have, widened it. It is horizontally, it's a horizontal stretch, which does flatten it out. If you imagine grabbing it at all the points and pulling outward, that's what's happening. What if I do what if I put a 2 here? What happens when I multiply the y with a bigger number?
It's gonna go flyer, so it's gonna go skinnier.
Not skinnier.
No?
We're now, it's wider again.
Oh, because it's the same thing with the half on the x.
Yeah, vertically, it's gonna halve vertically. So instead of pulling out, I'm now pulling down. I'm pulling this line, this curve towards the horizontal line now. And in fact, this should be the same as what we had before when I put a 1/2 here. They make the same, it's similar. Or it's the same, right? Let's see. Oops. All right. Can you tell which of these is the correct one?
Which was the correct one?
Yeah, think of this like A, B, C, D.
The bottom.
+4.
Y plus 4 equals x plus 4.
Do we agree?
I agree because +4 makes it go negative.
Yeah, it does the opposite, right? So it'd go left 4 and it'd go down 4. So, good. I'll just refresh and we'll get another one. How about that one?
That could be -1.
Good.
Let's see. +6.
Top one.
Awesome. This makes sense then?
Does Exponent have anything to do with it?
What's that?
Does Exponent have anything to do with it?
It's creating the shape of the
It
curve,
just, okay, but that doesn't,
but that has nothing to do with the transformations of coordinates that we're doing.
okay.
We could make much more complicated shapes, and we'll eventually, but we'll build up to it. But this is already a more complicated shape than y equals x. Now this is y equals x squared, and it all works the same. Is that okay? All right. No homework for right now. We just did that with parabolas. We did that shifting it around. Next time we will add to that, stretching them, flipping them upside down. That's just multiplying the numbers. But that's pretty good for right now. Hopefully that made sense.
Yeah, I understand that.
Yeah, you may. If you guys have other things to work on, I'll give you some time right now.
I'll go.
Yeah.
So in the classroom, what does the dupe mean when it's next to it? Does it mean duplicate?
Yes. So I originally made those homeworks. I guess I did them after the test first semester. I put them in the grade book first semester to help people study for the test, since that stuff was after the first test. It was for the second test, that was in this semester. I sort of opened them back up so that people could fix their grade or retake those assignments.
Okay, and then that's this one, right?
Yes, you just take them again, and because Google Classroom is linked with the Plus portal, because I've already added those the Google Classroom grades without the dupe,
Yeah.
I've already put those into the Plus portal, and now Plus portal won't let me associate them with another column. So
Okay.
I made another classroom thing called
Oh.
dupe,
Okay.
and now I can put those into second quarter.
Okay.
But it's
Alright.
the same MyOpenMath file.
All right, that makes sense.
Assignment.
Then also, so I'm at 8%. So I'm assuming that the fact I don't have a 0 means that one of these is from this quarter. So I'm assuming it's this one. This one was at a 37, but I've been working on it. So now it's at that. So just letting you
Okay.
know that I'm
Good, good.
attempting to do
Okay,
it.
yeah. So for you, have you taken the test?
No, not yet.
That's why you're at. so
Yeah,
low.
no. Oh, I know why I am. I'm
Yeah.
not arguing about that. 'Cause I understand it's 'cause I missed a lot.
Right.
I was just saying. I'm assuming since it's not at a complete 0, that one of these
And I also
is
gave
something.
I
Yeah.
also gave everybody credit for the matrix determinants and the Kramer's rule.
All right.
since,
I was actually really confused how I didn't just have a 0 in the class. So I was like, I assumed that it was either this like this
It might
homework
be,
or one of
yeah.
them. So I was like, just in case that's not from last quarter, I'm gonna work on it.
Yeah, and I did give everybody credit for
Okay.
2 small assignments. So,
All right, that makes sense then.
yeah, work on those to help you get ready for the test. So, however many assignments there are, there are 4 there. That'd be 40 points.
Okay.
Each part of the test is each worth 100. So,
So is a test on MyOpenMath?
yes, yeah.
So when I take it, will I take it on the computer then?
Yeah,
Okay.
I mean, you'll have scratch paper
Yeah,
to work it out,
alright.
but yeah.
Okay.
Also, if you go to the classroom, you do have, if you go to our class, in the coursework, there is the recordings YouTube playlist here. If you click on that and go to that playlist, I'm doing it there if you want to see. It's just here in the coursework, there's a recording playlist. Click that.
That has all the lessons.
Yeah, so whenever I've recorded myself going over that first homework, the second homework, I did the second homework again because we have 2 sections of Algebra 2. I don't know what happened to linear relationships 1, but here's 2. Here's going over the determinants. He's going over Kramer's rule. He is studying for part 1 of the test. He is studying for part 1 of the test again. He is studying for part 2 of the test. He is studying for part 2 of the test again. Here's how to do the some of those matrix things on your calculator. And I added a few more things. And then we did a retake review also.
Okay.
So there's a lot of stuff that,
All right.
if you're alone, you could use that to help you work through the assignments and study. But I'd also recommend coming in to get help. So
Also, have you ever listened to the microphones?
No.
Because I was looking like in the really like abstract like indie like bands and I found them. And immediately first thing I did is I texted Shay like, hey, have you ever heard of them? Like, I listened to a song or two. I'm like, all right. Because they only have like 250,000 listeners. And I know if anyone would have heard from them, it would be Shay.
yeah, he's
Like a music encyclopedia. You know,
he's very eclectic. With,
yeah. Good old Shay.
I think he said he's going to be back next semester. There's going to be online.
Oh yeah.
So I kind of.
Because I went on a visit there for cross country. I saw him.
Oh, no kidding.
Yeah, well, I didn't like necessarily like actually get to talk to him.
Right, but
I was like texting him throughout the day, but we went into one of the buildings and I saw him in class.
oh, really? That's funny.
Yeah. I saw someone with really long curly hair. I'm like, that kind of looks like Shay. I'm like, well, there's like 1,000 kids at this college, so it probably is Shay.
Yeah,
That was nice.
yeah, he did have long curly hair. Last I saw him. I imagine he'll be back for breaks. So
Yeah.
I guess when he comes back, he'll probably stay back, and I don't know if he has to quarantine or what.
I was talking to him about running. He was pretty much like, yeah, you know, I'm happy I don't run in college, but I'm really upset that I don't do anything now.
Oh, he doesn't.
Yeah, he doesn't run.
It's
or,
liberating.
Like, do like
I mean, it's
much
nice.
physical activity. I think.
It's nice to be lazy sometimes.
Yeah.
At least he's got time to listen to music, I guess.
Well, yeah. That's all he really does right now. It's really funny to see how, like, for example, like Brady Moran, how him and Jay have just gone like complete polar opposite. Like,
Have they?
yeah,
Brady hasn't responded to last couple messages I sent him.
I don't think they're like friends anymore
Really?
because I think Brady's pretty extreme, and I mean so is Shay. But I think Brady's pretty extreme in some of his views now,
Really?
according to Shay. According to Shay, at least.
So is Shay, right?
Yeah, but yeah, exactly. So is Shay.
But the other way, I guess.
Yeah, the complete polar opposite way.
I should give Brady another try. I think he's just busy.
Yeah, well, I think he's going into the military.
Yeah, I heard that.
Brady Moran. So,
Really?
yeah,
What form of what branch?
I don't know. It might be Air Force.
Oh, you mean like permanently?
I don't see. I thought maybe he was just going to like help pay with college.
Yeah, that's it.
Apparently, he wants it to be a career. I guess.
Okay.
I don't think he's gonna be a soldier. I think he's gonna do like, you know what I mean, maybe something medical in the military. I don't know. He's pretty smart. So.
Doesn't he like engineering and all that?
Yeah, he was going into.
Oh, that's
he could be
right,
an
yeah.
engineer.
Yeah, maybe that's what he's doing. Maybe he's gonna be like, I know that like, cause I thought he was just doing it to maybe like pay off tuition or do something, but
Yeah.
my mom's pretty good friends with him, and she was like saying that no, he's like, I think he wants it to be a career.
Okay.
So I was like, interesting.
Yeah, he was going to go into like nuclear engineering, and then I don't know if that's changed or. And then I thought he was going to do the ROTC.
Yeah.
Yeah, who knows? Maybe he likes it. You know, you don't know until you try it.
Yeah, I don't think it's for me, but if he wants to do it.
They'd take care of you. I mean, well,
See, that,
They do take care
sort
of
of, yeah.
Basic
If you
shit.
survive.
Yeah,
you gotta get
exactly.
basic.
Like all the benefits would be nice.
Yeah,
But I really don't want to go to basic.
Let's go.
Or like see people
Air
die.
Force is the best one, probably.
Air Force?
Air Force is, they have the best benefits.
Yeah, exactly. No, you get
But you
like,
can't be an
my mom
infantryman.
literally she was in the army and like she could see like the Air Force and like this nice air conditioning
Oh yeah,
area.
they get like hotel rooms.
Yeah, they get everything.
Air Force? Yeah.
Yes,
Air
they get
Force-
like everything handed to them.
They get, it's all nice and paid for.
My-
Yeah,
My grandpa,
Okay, but people in the Air Force, if they're not in planes, they're like flying drones. It kind of makes sense. Like Army and like, they're like more.
well, the
on
Navy's-
ground,
the big one, the Navy has basically their own Air Force and their own Army.
like- Yeah.
Navy's just, they're just badass.
My grandpa was with the Navy, and he was on like the USS Reptilicus, which he said was basically a grocery store. Like it was basically just a supply ship. For the, so he's basically just like floating around on the USS Kroger. He
Just
said they,
snacking on some food every other minute.
yeah, he said he had ice cream like every night, and like
That's so
My dad was in the Navy, and I don't know if you know who. I forget his last first name. Robinson. He played for the Spurs.
Nate Robinson?
No, Duncan Robinson. He was a center for the Spurs. He got Hall of Fame center. He was an admiral.
nice.
Like, on my dad's ship, so like.
That's awesome.
Duncan?
Yeah.
Yeah, I bet
Yeah.
that'd probably be a pretty sweet deal.
Yeah, he had a quadruple double.
Yeah, I
He had
did.
one ring with the Spurs.
And my grandpa was on radar, so like he had the cushiest job. I guess all the other people hated the radar people.
You just
because
sit
you
there
had
and
to-
be like, oh, we got a beat.
Yeah, you have to keep your eyes rested.
Oh, that's
so
his name. Never
you
mind.
slept
Oh,
in
yeah.
and like
That'd be a fun job.
Yeah.
Just sit there and be like me.
I hate being I hate heights.
Until
so I
something
could
actually
never be in
happens,
the Air
you're like,
Force,
oh,
but
boy.
I hate being I hate being in like open water, like not being able to see land.
Oh,
Like,
yeah,
being in the
that-
lake is
that would
fine.
scare me.
Or
Yeah.
like, if you like going like fishing, it's not bad going out in the ocean. But if I was like living like going like I'm like in the complete middle of the Pacific Ocean.
Yeah, like if
That'd be
every morning
scary.
I got up and I just saw ocean, I'd be like, oh my god.
This, like if I know there's not land
with
from
my
like
brother,
1,000
when he was
mile
stationed in
radius, I would
Japan.
need it.
On the boat every
So-
morning. It was so pretty though.
Yeah, I bet it's gorgeous sitting
yeah,
in the
I've
morning
hated
at
the
night,
water.
the sunset and all that.
oh yeah.
And just knowing you can't touch land, like you're on
That
something, man.
And then imagine all the
24/7.
storms too.
Oh, the
That's
storms are the worst.
They'd probably try to avoid the storms though.
Oh yeah.
They do, yeah. But sometimes
His
you know, they just
first-
gotta go right through.
I think I'd be more
Like,
focused
they-
on the what if. What if something happens? It's like, well,
There's
I guess we're going swimming.
Yeah.
Yeah, and it's like a mile deep.
Someone
Yeah,
accidentally
they-
shoots
I don't think they
the
his ship
floor
could
of the
really
boat.
defend itself that well.
When they were working on it, because it was in dry dock for, the boat itself was in dry dock for 10 years. And there was like crewmates on the boat that had never went out to sea.
Yeah.
And so my brothers went out for the first time towards the end of his fourth term, like 4-year term or whatever. And like he was like, it's so different. Like they were literally sitting on Japan for almost all of his like year
Yeah.
thing, and he was like, it was so much more fun like to go out, and like they went to, I don't remember what the place was called, but it was he thinks like that was the best part, was just getting to go out. And like there were so many, he's like in the engineering part,
Yeah.
and like there was fires, and he had to go in for someone one time on the boat because there was a fire, and that boat was terrible. He said he's so happy to be
It's
on
dry
a new
dock
one.
for 10 years, I bet.
If they couldn't get it fixed, they were gonna have to they were gonna pull the boat with another boat or something
Sure.
up, like back to the U.S. because it was that.
Oh, that would suck. 'Cause then you definitely have to avoid storms the whole time, so
Yeah.
you're gonna go for like
Yeah. They were lucky.
a 6-month trip, and it should be like 2 months.
Imagine you accidentally get caught in a storm. Hey Cam, what's that out the left side? That's the other boat.
Hey, were
Oh,
we
yeah.
pulling something earlier? Yeah, that's gone.
I
Sorry,
think it
someone
was.
didn't strap it up right.
Down there by the Titanic somewhere.
I think a story he told me, I think it was from him, that they were at this dock at, during it was a World War II, so they were moving island hopping sort of. And it was this really foggy day, and like, I guess he had no idea what was going on and all of a sudden, like something changed and the fog just completely went away, and they had this huge fleet.
Right in front of them.
Yeah, and the fleet was just like, get out of here, because they were hiding. They were kind of hiding while they were docked.
My brother's most memorable moment is when another U.S. ship showed up with more Marines on it, and the Marines were terrible in the bar, so then he had to break
Oh,
up
God.
multiple fights.
Yeah, that would have been crazy.
And then he got punched in the face when he was pulling one guy because his buddy was drunk and he wasn't. So he was pulling his buddy,
I know,
well,
I
his
see
buddy
the
went to
station.
swing at the other
I know.
Yeah.
Push him.
We're going to the.
I'm talking
He goes,
to
"I think
Brandon.
I'm
I'm talking to
fine,
Airport.
I'm fine."
But I haven't been talking
And then it's
about
like,
it.
I've been talking to
I'm
Brandon.
sorry.
Yeah.
The next morning.
The guy from the army, he's like,
And
Thanks.
his
I could put you down.
favorite part was we went to this like ice castle thing.
Like, oh no, it's warm, but it's Jordan.
And he said that was his favorite.
And laugh.
And he went
Like
to
the AC guys.
Pearl
Is that
Harbor
looking at ATL, I'm
museum.
not going
I legit helped
And like, you know how they don't have anything about
They don't what?
They don't have anything about Pearl Harbor, like saying that they were
That's what I want. I want to get
in the museum.
I'm stuck in like
And Japan.
Kentucky. 'cause
Oh,
I've been
really?
stuck in
Yeah.
Kentucky for like a year.
And like that was, he was like, that's just so weird
Like my friend Gabe.
that like they don't, because they're like the ones who started. They
Like no one
don't
wants
say
to
they
go to
did.
the state. Like I've
Well,
been to Missouri.
What do we do about
The lakes.
Hiroshima?
You know what I'm saying? If
Literally.
you're not by the lakes, it's pointless. We're going.
I mean, you're good to go, Serenity, if you're still there.
I thought they called it the Pearl Harbor Museum, but then they don't talk about how they bombed Pearl Harbor.
Literally.